Okay, so we're going to begin factoring here. Now, when you're factoring, no matter how complicated of a factoring problem we have, the first thing I always check for to see if there's a GCF in our polynomial before we do any other type of more complicated factoring. Okay, so let's just start with that. So you kind of look for and say, okay, I have two terms here. I have one term here, one term here. So what's in common with that? I'm going to look for the numbers first, then I'm also going to look for any variable that I can pull out. So here I look at the numbers and I see a 4 and a 12. So I look for common factors. So I think, well, the 4 factors are 1, 2, and 4, and 12 has a 1, a 2, a 3, a 4, a 6, and a 12. So the greatest common factor that I can find there is a 4 that goes into everything. And then I'm going to write a set of parentheses. So what this GCF is, by the way, let's write this down. GCF is actually the reverse of distributing. And one of the things we can actually do to check our answer, this would be an I, let's spell correctly, distributing, okay, is that we can check our answer by actually distributing the number that we factor out, and by distributing that back in. As long as we get the original, then we're good to go. And we will check all these when we're done. We'll check them down here. And that's a good thing to do, because if you check it and you don't get the right answer, then you factored it wrong. All right, so when you factor out, think about distributing. When you distribute, it's multiplying. So again, think about let's say you had 2x plus 3. When you distribute, it's 2 times x, right? So you're multiplying, and 2 times 3 gives you 6. Well, GCF is the reverse of that. So if distributing is multiplying, then factoring is really dividing. And it's trying to break a polynomial up into its factors, and you do that by dividing. So I'm going to pull a 4 out. So what we can write is, and I'm sure you've seen this before, and I don't usually write this, but I see a lot of other teachers do this, so let's try to give this a shot. What we're actually doing is dividing this term by 4, and then we're also going to divide this term by 4, and let's see what happens. So 4 over 4, that cancels, becomes 1, and you're left with 1x. So we put that 1x, whatever's left right here, and then we have a minus sign, so we keep that, and then 12 divided by 4, right there, gives us a 3. All right, so let's check our answer. So we're going to take our answer, and we're going to use the distributive property. So we're going to distribute the 4 back in. And again, multiplying is what distributing is. So let's multiply the 4 back in. So 4 times x gives us 4x, and 4 times negative 3 is minus 12. So then we just have to look at this and say, okay, does this check that we just have, does that match the original answer? And say, yeah, it's good. So what does that mean is that our GCFing here was correct. All right, at least we factored correctly. All right, let's take a look here. Again, if you need to do this, you can, again, think about all the factors of 14. So we have 1 and 2, 7 and 14. 28 is 1, 2, 4, and 7. And what else do we get? 14 and 28. So we're looking for the greatest common factor. So I see this is a 14. And this also has a 14, so the GCF is 14. So we can pull that out. And then also with the variables, this has an x, this has a y, and you can't pull an x out of this one, you can't pull out a y out of that one. So there's nothing in common there. So we can just pull that 14 out. And then again, think about GCFing as dividing, so I'm really dividing this one by 14. That cancels, leaving us x. Dividing this by 14. Now here, 28 over 14 gives us 2. So we have plus 2. And we still have that y hanging out there, so we're going to keep that. And then again, as a check down here, let's take our original or our answer, and you could distribute it. Now, I think you should be able to at least look at this and see if you're right, but I'm not just going to go, look, C is the right answer. Let's just check. So 14 times x, we have 14x, and 14 times 2y gives us 28y. So we look at this here, and we have 14x plus 28y, and that checks out, which means that is a good factoring. All right, right here. So what is in common with a 25, a 15, and a 5? You should see that a 5 is in common with that. All right, so again, we're dividing all these by 5 to get what's inside here. So 25 divided by 5 gives us 5x. This would give us 15 over 5, which is 3y and minus z. And again, I'm not really looking at the variables because this is an x and a y and a z. They're all different. So I can't really pull any variables out of those. Now that's going to change. We can certainly do that. And again, as a check. Now without actually rewriting this, so 5 times 5x is 25x plus 5 times 3 is 15y. And then 5 times negative z is minus 5z. And then looking up here at the original, looks like we got it. So that is, in fact, our answer. Excuse me. Okay. So we're back to multiplying, and again, there's something that we need to get out of this, and it's down here. So we definitely need to do this, and you'll see why. So x times x gives us x squared. X times 4 is 4x, and 3x, and then 3 times 4 finally is 12. So notice we're adding the 4 and the 3. Do you see the 4 and the 3 we're adding together? And it gives us 7x in the middle. And then plus 12. Okay, multiplying this out, we have x squared plus 2x minus 5x minus 10. And combining the middle terms, okay, again, we have x squared and minus 7x minus 6x plus 42, which is x squared minus 13x plus 42. All right, now here's the key thing here. Notice the middle term. So these are the middle terms. Right here. So notice that the middle term comes from the sum of the inner and outer multiplication. So this is the outer. So this is the outer, and this is the inner right there. Okay, and when you do that, notice you get the 3 and the 4. The 3 and the 4 were added together to get the 7. Same thing here. This negative 5 and the 2, right here, a 2 and a negative 5 were added to get the negative 3. And then again here, the outer and the inner, that negative 7x and the negative 6x were added together to get that middle number. So the middle term comes from the sum of the inner and outer multiplication. And then notice that the last term, which is this thing, comes from the product of the last two terms. So what we have is the 3 and the 4. When the 3 and the 4 are multiplied together, that those two give us the 12, and then the negative 5 and the 2, when they're multiplied, they give us the minus 10. And when the negative 6 and the negative 7 are multiplied, they give us the 42. Okay, so where does this get us? So just to recap, look how this is really in factored form here. So to recap, 3 and 4 multiply to this number, and 3 plus 4 add to the middle number. So let's take a look at that. So we have to find two numbers. So here we're going to factor this trinomial here. And this is something you've done before. Okay, so this should just be a refresher. So we have to find two numbers whose product is 4, right? So that's what the product has to be. So if we're talking product, let's think about the factors of 4. So 4, so I'm going to write 4 down here. So 4, to get 4, we can either multiply a 1 and a 4, or we can multiply a 2 and a 2. But remember, not only do we have to multiply to get to this 4, which is here, but we also have to add to get the 5x. Okay? So think about if we add these. If we add 1 and a 4, right, that's going to give us a 5. If we add 2 and 2, that's going to give us a 4. And here I'm just adding them. So this is the sum of those two numbers. Well, we're looking for this middle number because remember, 3 times 4 is 12, but 3 plus 4 gives us the 7 in the middle. Okay, so which pair do we want? Since we're trying to add the 5, we want the 1 and the 4. So we're going to factor this into x plus 4 and x plus 1. And then watch what happens. And again, this is going to be our answer. This is our answer, but let's not circle it yet. Let's just check. So again, how do you check something? Well, if you factored it, that's like dividing. So we're going to check it by multiplying those two items together. So let's do that. So x times x, that gives us x squared. So x times 1 is 1x, or just x. And there's 4x. And then plus, and this is a plus. 4 times 1 gives us the 4. So we got the 4 on the end, and then I circled it up in green up here. So we got the 4 here. We just have to make sure that those two middle numbers add to the 5, and we're good. And I think we're okay on this one. So we have x squared plus x plus 4x is 5x plus 4. So we got it. So that means this is correct. And again, this factoring, when there's no number in front of this x squared here, is actually not that difficult. In that you're just looking for two numbers. It's like a puzzle. You're looking for two numbers that multiply to this number and add to this number. Okay, let's do the same thing with this over here. All right, so this is what I do every time. And factoring is not staring at this and trying to figure it out, because some of these factorings get very difficult. These should be a bit easy because you've seen a bunch of these before. So here's what I do. This is how I factor. I take 20. And I don't just list out factors. Now we're actually listing in factor pairs because we're going to factor this into a pair of factors. So I'm listing out the 1 and 20. So instead of just listing 1, 2, 4, 5, I'm listing them out as pairs. So 2 and 10 and 4 and 5. All right, so the first term here, so what times what is x squared? Again, that's just going to give us our x. And then so all of these pairs multiply to 20. We're good with that. And we just have to ask ourselves, what pair here sums up to 9? So 1 and 20 is 21. 2 and 10 is 12, and 4 and 5 is 9. So this is the pair that we're looking for. And 4 times 5 gives us the 20. 4 plus 5 gives us 9. So those are the two factors we're looking for, x plus 4 and x plus 5. And again, let's just give that a quick check. Let's just write them down. All right, x times x, x squared. Okay, there's the 5 we're looking for, right? And here's the 4. Now we're going to add them up and get 9, and then 4 times that 5 down there is 20. And then what do we have? X squared plus, here's our 9x in the middle, and then plus 20. All right, that means we have the correct factorization. That's all that's going to be. All right, now I'm going to talk about this quick here. So when we factor these trinomials, we first have to look at the last number. But not only do we look at the last number, we have to look at the sign. Because remember, the two numbers have to multiply to this number. So let me just write out an example here. So let's say x squared, and we'll just use one of the last ones that we did, x squared plus 5x plus 4. And then here, what we'll write is x squared minus 5x plus 4. So that's what that means with a plus x. So that just means this is a plus, this is a minus, and both of these are a plus. Now these are going to be kind of treated similarly, so let's figure this out. So let's actually factor both of these and watch what happens. All right, again, when I factor, I think about this 4. So I think of 4, and we have a 1 and a 4, and a 2 and a 2. So remember, from the last slide, we figured out that it was, in fact, the 1 and the 4. So we put an x plus 1 and x plus 4 in either order. The 4 or the 1 could go here or here. Now, when we checked that, we did get x squared plus 5x plus 4. But notice this factoring. We're trying to find two numbers that multiply to 4, but add to negative 5. Now, if you consider that all these are positive, there's no way we can add to negative 5. Well, there's actually two ways to multiply to 4, excuse me, with a 1 and a 4. So let's think about this off to the side. So 4 not only equals 1 times 4, but since this is positive 4, we could also have a negative 1 times a negative 4. Okay, and a negative 1 times a negative 4 is a positive 4. And not only that, negative 1 and a negative 4, they have a sum. I got to put this back. They have a sum of negative 5. And look, we have a negative 5 right here that we have to sum to. So this factoring is actually going to be x minus 1, x minus 4. All right, so what does that mean? So if you look at the last sign, if the last sign is positive, you can either have plus plus, like plus 1 times plus 4 gives us 4, but you could also have a negative times a negative. So with the last sign, and this only works for the last sign of the constant term, if you have a plus, that means you have to have the same sign in your factoring. So that means you either have, the factoring is either plus plus, or you're going to have a negative times a negative in here. All right, now let's do two different factorings. Now notice here the last term is negative, and we have to figure out what that means. So let's just make one up here. Let's say we have x squared, let's say plus 3x, and let's actually have minus 4. And let's have x squared minus 3x minus 4. And again, these two factorings are going to be very similar. And again, we're looking at a 4 here, so let's do that down here. Again, we're still looking at a 4. 1 and a 4 and a 2 and a 2. But now, we don't really have a 4 here. It really is a negative 4. So how do you get a negative? So we have to pick two numbers over here. We have to pick two numbers that when we multiply them together, we're going to get a negative. And the only way for that to happen is if one of them is negative and one of them is a positive. Okay, so let's just think about this for now, because both of these answers are the 1 and the 4. Okay, but in a slightly different way. So let's write this down. So let's think that when you multiply a 1 and a 4 together, you could have a plus 1 and a negative 4, because positive 1 times negative 4 is negative 4. That's okay. Now the other option you could have is, well, what if the 1 is negative and the 4 is positive? Okay, you still get a negative 4 when you multiply them together. Okay, but let's think about their sum. Now we have a 1 and a negative 4. So we have a 1, positive 1, and we have a negative 4. Well, its sum is negative 3. And when you add a negative 1 and a positive 4, that sum is actually a positive 3. You know, like when we add, if you add with different signs, you keep the sign of the bigger number. So you go 4 minus 1 is 3, and you keep the sign of the 4 because it's bigger than 1. This one, we're also going to keep the sign of the 4, but it's positive. So let's come back up here to our factoring. So one thing we know, when this last sign is negative, so up here, when the last sign is negative, instead of having same signs, we're going to have different signs. And again, this is probably something that you know from Algebra 1 and Algebra 2. So we have different signs in our factoring. So that's either going to be a plus then a minus in our factoring, or you're going to have a minus then a plus. All right, so let's think about which is which. So both of these are going to start off with an x. One's going to be plus, one's going to be minus. This is also going to be x, 1 plus, 1 minus. And again, because the only way to multiply to get this negative 4 is if the signs are different. But then we have to figure out which one of these do we want, the 1 or the 4, to be positive. Well, if you look right here, this is a positive 3x. So when you add two numbers, in order to get a positive number, if the signs are different, the bigger number has to be positive. So that just tells us the 4 goes here and the 1 goes there, because 4 minus 1 is positive 3. Now in this case, when we have a negative 3x, and again, when you add two numbers, one positive and one negative, the only way to get a negative number is if the negative number is bigger. So that means the negative is going to go here and the positive is going to go there. Now we're going to do lots of these examples. So if you don't get this completely walking through this, we're going to go through a bunch of examples, and hopefully you'll get it sooner than later. All right, here we go. One thing I notice about all of these is that this last number right here, they're all positive. So this entire page is going to be same sign. Okay, meaning we're going to factor it and they're going to have the same sign. So that really means then we just look at this middle number and that's going to tell us what sign to use. All right, let's pick a good color here. All right, so even though I know the signs are the same, they have to add to a positive, so I know that both of these are going to be some sort of positive number. And we can write that down. And I need to find two numbers that multiply to 6 and add to 7. Well, I always write down the 6 and I list out factor pairs, 1 and 6 and 2 and 3. And then I sum them. So 1 plus 6 is 7, 2 plus 3 is 5. So we're looking for the 7, so that's the 1 and the 6. 1, 6, done. Notice 1 times 6 gives us 6, and then the 6x and 1x will give us the 7x in the middle. Okay, next one. We have a 20, and that's going to be a 1 and a 20, a 2 and 10, and a 4 and 5. Now, I think we already did this one. So again, we're looking for a plus, and this tells us that it has to be the same sign. And if they're the same sign and add to a positive number, that tells us they both have to be plus. All right, so which pair adds to 9? That would be the 4 and the 5. 4, 5, done. Right here. Again, what does this tell us? Same sign. Now, I don't know if it's plus or minus. That doesn't come until you look right here. That tells us, in fact, they are both plus. This only tells us they're the same. Okay, so we're going to factor the 12 into factor pairs. 1 and 12. I put a 21 there. That's supposed to be a 12. and then 2 and 6 and 3 and 4. All right, so we're trying to add to an 8. Let's see here, 2 and 6. Add to 8. So that's going to be a 2 and a 6. And that's it. Okay, example 2. Very similar problem. Okay, that's a bad parentheses right there. All right, so again, this tells us, what does that sign tell us? That tells us they're the same sign. However, that negative tells us that they're both negative. Because when you add two numbers up and they're the same sign, they have to be a negative in order to add to a negative number. All right, so we have a 12. So again, we have a 1 and a 12, 2 and a 6, 3 and a 4. And we have to add to 13. That would be the 1 and the 12. So 1 and 12. Okay. All right, so we have that 6. We have to factor into pairs, 1 and 6, 2 and 3. And again, this plus tells us they're the same sign. That tells us they both have to be negative. And we need to add to a negative 5. So if they're both negative, now be careful here. This is where you can think, well, a 6 and a negative 1 is also a negative, or sorry, negative 6 and a positive 1 would be a negative 5. Well, that's true, but notice in order to get that negative 5, 1 would have to be negative, 1 has to be positive in order to get negative. This is the only pair that if they were both negative, you would get the negative 5. Note, if these were both negative, you would get a negative 7 when you add that up, and we don't want that. So it's these pair here. That's it. Okay, we got that 30. So factor pairs 1 and 30, 2 and 15, 3 and 10, let's see, 4, 5, 6, 5 and 6. I almost forgot about. That's a good thing because I think that's the answer. All right, again, what does that plus tell us? It's the same sign. All of these on this page, this is positive, tells us the same sign. This tells us they both have to be negative. All right, so which pair adds to negative 11? Well, the only ones that work are, and again, they both have to be the same sign, so negative 5 and negative 6 will do the job for us. All right, this one. If you notice, every single problem on this page, the last sign is negative. Right here, right there, right here. And all the other ones are negative. That's going to tell us, and again, when you FOIL, and I'll show you, I'll check a couple of these. When you FOIL, the last two numbers always multiply to that number. So when we find factor pairs, in order to multiply to get to a negative number, one has to be plus and one has to be minus. Okay, the only way for that to work. All right, now this positive, what does that tell us in this case? Well, this tells us they're different. This tells us the signs are different. Now, this can't tell us they're the same because you can't have one thing telling us they're different, one they're the same. That just doesn't make sense. So what does that really tell us? That positive tells us which one is the bigger number. Because remember, we're going to add two different numbers together in order to add to a positive 2. So let's think about 1 and 3. It's either going to be a minus 1 and a positive 3. That's one possibility. Or we have a positive 1 and a negative 3. All right, so which pair adds to 2? Well, that's going to be this one because the 3 is bigger. The 3 is positive, it's bigger. And when you add a negative 1 and a 3, you're going to get a positive 2x. So that means the 3 has to be the positive 1, and the 1 has to be negative. Now, just in case you're doing this, if you happen to ask, is it okay, question mark, to write x minus 1 and x plus 3? Absolutely. Just note that the 1 is the negative 1, the 3 is the positive 1. It doesn't matter in what order you have the two factors, as long as you have x minus 1 and x plus 3 in either order. That's perfectly fine. All right, let's actually check this, and I'll show you that this actually works. So let's write x plus 3 and x minus 1. And again, I'll try to go through and explain why this works. So it shouldn't be too much difficulty why x times x gives us the x squared. All right, x times negative 1 is negative x. Right here, 3 times x is 3x. Now, watch what happens here. When we do the L FOIL, that's the last two numbers that we're doing, we have a positive 3 times a negative 1. Note that the signs are different, so when you multiply, that's what gives us this minus 3 right on the end. That's why we look at that first, because that is a good clue as to what the sign of the numbers are. And then combining like terms, negative 1x plus 3x, this is supposed to be an x, is positive 2x. And then we just keep the minus 3. And notice that this matches the original, and that means that our factorization that we did right here is correct. Okay, same with the rest of these. Let's try to get through these quick. I know I can just talk on a lot of these things, so let's just blast through them here. So 1 and 18, 2 and 9, and 3 and 6. Again, that sign there is negative, which tells us the signs in our answer are going to be different. So 1 plus, 1 minus. All right, so which two add to 3? And again, if you just add these straight up, none of these add to 3. We have to think that one's plus and one's minus. So remember, when we add numbers with different signs, we think about subtraction. That's why this right here is going to work. And the 6 and the 3 are going to give us a good result, because a positive 6 times negative 3 is negative 18. And 6 minus 3 gives us positive 3. Okay, and we're good. All right, same thing. This sign is negative, so definitely have 1 plus. And we have 1 minus. And again, we have a 12. And again, if you're looking at this video and you could easily go through these three, just go ahead and factor them. You don't have to watch the rest of this video. If you know what you're doing, just go ahead and factor those. If you can factor these, the rest of these, you're gold. You're good. All right, we have a 3 and a 4. All right, again, with different signs, we have to think about subtracting. And that's how you combine numbers with 1 plus and 1 minus. You think about subtracting. So 12 and a 1 is an 11. 6 and a 2 would give you a 4, and a 4 and a 3 would give you a 1. So this is a negative 1 sitting here. So we're going to use the 3 and the 4, but because we need the result of a negative, that tells us that the bigger number must be the negative number, and the smaller number must be the positive. And we're good. Okay, this one. All right, 60 has, I think, a good number of factors here. So we're just looking for a difference of 4. So it's definitely not 1 and 60. We got 2 and 30, 3 and 20, let's see, 4 and 15. 5 goes in. 5 goes in 10, 11, 12 times. And 6 goes in 10 times. 7, 8, 9, 10. Okay, I think that's it. Now, notice what I'm doing every time. I'm listing out, not to cross these out, I tried to put a box around it. I'm listing out the factors every single time. If you're having trouble factoring and you're not writing this down, that's why you're having trouble. I'm telling you straight up. Write these down. You just figure out which pair adds to the middle number. You just figure it out. But if you're not listing them all out, how are you going to find this out? All right, so we're looking for 1 plus, 1 minus, and we're adding to a negative 4. So it looks like this pair has a difference of 4. And because the 4 is negative, that tells us that the bigger one must be the negative one, and the smaller one must be the positive one. Okay, and I think that'll work out for us. Okay, just a couple more here. I think we have some special cases coming up and probably some GCFs that we still have to do. All right, 64, 1 and 64. 2 and half of 64 is 32. 3, 4, and 16. 5 does not go in. 6 does not go in. 7 does not go in. And 8 and 8. Okay, and nothing bigger than that will go in except these numbers. All right, so 1 plus 1 minus. Again, we're looking for the difference. So it looks like these two right here, 16 and 4. And because that number is negative, the bigger one is going to be negative, and the smaller one will be positive. Okay, 54. Interesting number there. We have to make sure that we get all the factors. 1 and 54. 2 and, let's see there, 27. 3 definitely goes in. That would go in 18 times. 4 does not go in because that's odd. 5 does not. 2 and 3 go in, so that tells us 6 goes in. And that would be 6 times 9. And then 7 and 8, and then do not. Okay. Okay, so which pair adds to, oops. Should I put that back up? All right, which pair adds to negative 15? And again, with different signs, we think about subtraction. So that would be this pair. And again, because of this sign is negative, it has to add to negative 15. That's going to come if the 18 is negative and the 3 is positive. And that's it. So we have those last two pages here. It's basic, same sign, different sign kind of stuff. And it really, as far as trinomials that we're going to do in the Algebra 1 section, it's only going to get a little bit harder than that is when we add some numbers in front of the x squared. Let's move on to different things here. Okay, if you can recall way back to, it would probably be the first video on factoring. Not the one with learn about quotient rule and product rule, but when we did factoring, the first thing we did was GCFing. And I said, no matter how complicated the factoring got, you always look for GCFing first. And that's what we're going to do. Because that makes things way easier. So let's look at these three terms. I see we have 2 and a 14 and 12. And if you recall from GCFing, we can easily pull out a 2 out of all those. So this would leave us x squared plus 7x because 2 times 7 is 14. And this would be plus 6 because 2 times 6 is 12. Now, when we did those, we didn't really talk about it, but all you could really do is GCF. But not only can you GCF on this one, but you can also still attempt to factor this. We still have to try to factor all this stuff. Okay, so we're going to keep the 2. And then we're going to attempt to factor this trinomial. And again, we have a 6. So I'm going to write a 6, which is a 1 and a 6, 2 and 3. All right, this sign right here is positive. That tells me that the signs are the same. And this is positive, so that tells me they're both positive, not both negative. All right, so we have a 6 multiplied to 6, but we have to add to a 7. So 1 plus 6 is 7. And you make one of these a 1 and one of the 6, doesn't matter what order. And then we're done. So the difference here is you're going to pull out a 2 first. Now, I will tell you, it would be a rare person, and I mean a rare person, and that can actually come up with this without doing any of this work right here. This is important. You have to GCF that out first. You don't want to attempt to go from here to here. We don't want to get a little bit of laziness going on, and because you're just going to be getting the wrong answer. Don't try to go from here to here in one shot. You GCF out the 2, then you factor that trinomial into 2 other factors. Okay, that's how it's done. Okay, let's factor here. So we got a 2, and a 24, so we definitely pull out a 2. However, I also see they all have x's in them, so I can pull this 1x out of all of them. All right, so that would leave x squared, because 2x times x squared is 2x cubed, minus x plus 12. Okay, and as a check, 2x times x gives us that. 2x times negative x would be negative 2x squared, and 2 times 12 gives us 24, and the x gives us the x. All right, so we leave the 2x alone. We don't forget about it. But we bring it down, of course. We bring this down every single time, just like we brought the 2 down. You can't forget about it. All right, so now we have this 12, and we have a 1 and a 12, a 2 and a 6, 3 and a 4. And now, you're not looking at this anymore. You're not looking at the 24. You're looking at the 12 right here. That's why we're getting that number from. And then now we're looking to add to a negative number. So this tells us same sign. This tells us they're both negative. All right, so which pair then adds to negative 1? All right, none there, I guess. So I was thinking this was going to work. Now notice, so we GCF'd. Now this is kind of interesting because I was thinking that this was going to work, the 3 and the 4. Okay. However, they both have to be the same sign. That means they're either both plus or both minus, and we came up with the fact that they had to be both minus. And a negative 3 and a negative 4, if we add those together, are going to become a negative 7. And we're looking for a negative 1 right here. All right, so that's not actually going to work. There's no pair of numbers then that will multiply to a positive number, positive 12, right, but still add to a negative 1. These numbers are just too large. That would have to be different signs. I would think if that were a negative number right there, if that were negative, then that would be a negative, and then we can use the 3 and the 4, 1 plus and 1 minus. So that doesn't actually factor any further. So we can't factor that any further, it looks like, and we can only factor that this far. And that's okay. Where in this one, we could factor this trinomial a little bit further, but that one actually doesn't factor at all. So be careful with that one. It doesn't factor into x minus 4, x plus 3, because both of the signs have to be the same, because that is positive right there, right? Yeah. Okay. All right. Hopefully we have a bit better result on this one. Let's pull 3 out, and we have an x squared plus 7x plus 12. All right, this looks better. All right, so I leave the 3 alone, and then I attempt to factor. It doesn't mean we can. We saw that we can't go on that one. And again, the 12 is the 1 and the 12, 2 and the 6, 3 and a 4. And if you do have this written on your paper elsewhere, you can certainly use that. I'm not going to yell and say, hey, you forgot to write it right down here. And you're like, well, I have it over here. So as long as you have it somewhere, that's perfectly fine. All right, so that positive 12, again, tells us same sign, and then this tells us they're both plus. And it looks like 3 and 4 then would multiply to 12 and add to 7. And we're done.